Hey everybody, it's your boy Winston, the change maker, the in tech change maker. So, as I discussed yesterday, I am planning on doing my GCP Data Engineering certification to eventually get a position in the Middle East, teaching it to people. So the first thing I got to do is pass the exam. Now, yesterday I just stated the reasons why I wanted to pass the exam, but what I want to do now as well is to be able to just discuss with people what is required to become a professional data engineer for GCP. So, a professional data engineer makes data usable and valuable for others by collecting, transforming, and publishing data. The individual evaluates select products and services to meet business and regulatory requirements. A professional data engineer creates and manages robust data processing systems. This includes the ability to design, build, deploy, monitor, and maintain and secure data processing workloads. So it's broken down into a wide variety of different sections. So at a current moment, we have 5 different sections and they all have different specific points. I'm just going to go through the points with yourselves and go through that with everybody. So section 1 is all about designing data process systems. So 1 of 1, designing for security and compliance. Considerations include IAM, so identity and access management, data security, which is encryption and key management, privacy, e.g., personable identifiable information and cloud data loss prevention API, regional considerations, data sovereignty for data access and storage, and legal and regulatory compliance. 1 of 2, designing for reliability and fidelity. Considerations include preparing and cleaning data, which is data prep, data flow, and cloud data fusion, monitoring and orchestration of data pipelines, disaster recovery and fault tolerance, making decisions related to ACID. Now that's atomicity, consistency, isolation, durability, compliance and availability, data validation. 1 of 3, you're looking at designing for flexibility and portability. Considerations include mapping current and future business requirements to the architecture, designing for data and application portability, e.g., multi-cloud and data residency requirements, data staging, cataloging and discovery, aka data governance, designing data migrations. Considerations include analyzing current stakeholder needs, users, processes, and technologies, and creating a plan to get to desired state. Planning migration to Google Cloud, so you're looking at the BigQuery data transfer service, data migration service, transfer appliance, Google Cloud networking data stream, designing the migration validation strategy, designing the project data set and table architecture to ensure proper data governance. That's just section 1. Now section 2, ingesting and processing the data. So you're planning the data pipelines. Considerations include defining data sources and sinks, defining data transformation logic, networking for fundamentals, data encryption. 2 of 2, building the pipelines. Considerations include data cleansing, identifying the services, so whether it be Dataflow, Apache Beam, Dataproc, Cloud Data Fusion, BigQuery, PubSub, Apache Spark, Hadoop ecosystem, and Apache Kafka. Transformation, so you have batch transformation, streaming, so that's windowing late arriving data, language, ad hoc data ingestion, one-time or automated pipeline. You have data acquisition and import, integrating with new data sources, deploying and operationalizing the pipelines. Considerations include job automation orchestration, so that's Cloud Composer and workflows, and CI/CD, so that's continuous integration and continuous deployment. Now, section 3 is all about storing the data. So you have section 3 of 1, selecting storage systems. Considerations include analyzing data access patterns, choosing managed services, so that's Bigtable, Cloud Spanner, Cloud SQL, Cloud Storage, File Store, Memory Store, planning for storage costs and performances, lifecycle management of data. 3 of 2, planning for using a data warehouse. Considerations include designing the data model, designing the degree of data normalization, mapping business requirements, defining architecture to support data access patterns. 3 of 3, using a data lake. Considerations include managing the data lake, configuring data discovery, access, and control costs, processing data, monitoring the data lake. 3 of 4, designing for a data mesh. Considerations include building a data mesh based on requirements by using Google Cloud tools, so that's Dataplex, Data Catalog, BigQuery, Cloud Storage, segmenting data for distributed team usage, building a federated governance model for distributed data systems. Section 4, preparing and using data for analysts. So 4 of 1, preparing data for visualization. Considerations include connecting to tools, pre-calculating fields, BigQuery materialized views, so that's view logic, determining granularity of time data, troubleshooting poor performance queries, IAM, so that's identity and access management, and cloud data loss prevention. 4 of 2, sharing data. Considerations include defining rules to share data, publishing data sets, publishing reports and visualizations, analytics hub. 4 of 3, exploring and analyzing data. Considerations include preparing for feature engineering, training and serving machine learning models, conducting data discovery. Section 5, so you're going to do maintaining and automating data workloads. So you have optimizing resources. Considerations include minimizing cost per required business need for data, ensuring that there are enough resources available for data for business critical data processes, deciding between persistent and job-based data clusters, so data proc. Section 5 of the second, designing automation repeatability. Considerations include creating directed acyclic graphs for Cloud Composer, scheduling jobs in a repeatable way. 5 of 3, organizing workloads based on business requirements. Considerations include flex on demand and flat rate slot pricing, index on flexibility or fixed capacity, interactive or batch query jobs. 5 of 4 is monitoring and troubleshooting processes. Considerations include observability of data processes, cloud monitoring, cloud logging, BigQuery admin panel, monitoring planned usage, troubleshooting error messages, billing issues and quotas, manage workloads such as jobs, queries, and compute capacities reservations. 5 of 5, maintaining awareness of failures and mitigating impact. Considerations include designing systems for fault tolerance and managing restarts, running jobs in multiple regions or zones, preparing for data corruption and missing data, data replication and failovers, Cloud SQL and Redis. So that's the entire exam guide. Now with myself, I'm looking to destroy it. I'm looking to absolutely own this certification. I'm looking to get 100% on every past exam, go into that exam 100% on 31st of December and absolutely own it. Now, I'm going to be documenting myself every single day. My goal is do one lab and do one talk through, let's say a section a day, and do at least one lab minimum a day every single day. I'm going to do that without fail. So if I can do that, that'll help me prepare for my exam, prepare for my certification, and also aids me when I have to do my 2 micro teachers to get this certification. So everybody keep viewing, and I'll be doing another video later. Peace.